Dear friends, welcome to a lecture of Analytical Solid Geometry. We are studying the sphere. In this lecture, we shall study the intersection of a sphere and a line. I have written here the equation of a sphere and a line. See, if this is a sphere, we may imagine it, and the line will intersect this sphere. In general, if the line is far away from the sphere, then there is no intersection of this. That means that depends on distance of the line, perpendicular distance of the line from the center. Is greater than the radius, then the line will not intersect the sphere. But if the line's position is like this, then this is the general condition or general position we shall consider. Then the line will intersect the sphere at 2 points. And we shall find out the coordinates of this point if we suppose these points are P and Q. And one more possibility will be there, the line will intersect the sphere in single point. So that is another case where if this is the center, then the distance of the perpendicular distance of the line from the center is exactly equal to the radius. Then the line will touch the sphere at single point. We will obtain this condition further in our next article. But here we shall consider see this position of the line, and then this is the equation of sphere we have written, and this is the equation of the line in space, and we want to find the point of intersection of this sphere and line. So this will be the case in general. Now for that purpose we write a point, general point on line 2, coordinates of a point of any point, you can say any point on the line 2. See, coordinates are, now how to write the coordinates of a point, general point on line 2, we shall suppose this is equal to r, and then we write the value of x, y, z from equating each ratio to r, and therefore x will be L into r plus alpha. So these are the coordinates of the point, LR plus alpha, and then what will be y? That will be mr plus beta, equating this y minus beta divided by m equal to r. So y will be mr plus beta, and what will be z? Z will be equal to nr plus gamma. So these are the coordinates of any point on this line. Now at the point of intersection, this point must be also on the sphere. So that means we are taking this case, and therefore if this is the P is the point on the line, P is also the point on the sphere, and therefore and the same thing for Q, but we shall suppose this is, if this is the point on the sphere, this point is a point lie on the sphere. Sphere equation is 1, lie on the sphere, then we have, then the coordinates of this point must satisfy the equation of the sphere. That means in place of x, y, z we can write the coordinates of the point of intersection, which is a common point. Then we will have LR plus alpha whole square plus MR plus beta square, etc. Next is plus 2 u into x, that is 2u, x is LR plus alpha, and plus 2v into y, y is mr plus beta, plus 2w, and z is nr plus gamma. And plus d is equal to 0. So this is equal to 0, and we shall simplify this. To simplify this, we shall see that we have to express this as a quadratic in R, and for that purpose we shall simplify it. And I can write first the terms of R square. Here if you expand this square, then it will be L square R square plus 2 L R alpha plus alpha square, and each term will be like of that type, and but in this, these are the square terms, 3 terms, and therefore R square term will appear in these 3 terms, and thus if you take R square common, then what will remain in bracket is L square plus M square plus N square. This will remain in bracket, and next what we will consider is 2R common plus, I shall write 2R common, and in bracket what will remain is you see the 2R term will be here, that is 2R L alpha, 2R M beta, 2R N gamma, and here is also the term of 2R, that is UL, if you consider, and then here this for this term 2R term is 2R into Vm, 2R into Wn. So, these are the terms of 2R, and but these terms can be written as 2R, and in bracket we can see L alpha plus U into L. So, L is common, and we can write in bracket alpha plus L or U plus alpha. So, U is common, U into L plus C, or we shall write first as it is, and then we can take the terms common. So, what is here is 2R L alpha plus next is M beta, and plus next is N gamma, and next is 2R is taken common UL plus here is 2R is taken common plus Vm, and plus next is Wn. So, these are the terms of 2R plus. Now, what are the remaining terms which are independent of R, that is alpha square plus beta square etc., plus alpha square plus beta square plus gamma square plus now 2U alpha plus 2V beta. You can expand this and verify 2W gamma plus D is equal to 0, or only the middle terms you see this is 2R, and here we can take what is common is L alpha and in this L alpha and UL. So, we can take L common and we can write in bracket alpha plus U, or that is R square into bracket L square plus M square plus N square plus 2R into bracket. We are taking L common, and in bracket it remains alpha plus U. Similarly, we take M common, and in bracket it remains beta plus V, and plus N common, in bracket it remains gamma plus W. This is the term of 2R, and next term we shall write as it is plus alpha square plus beta square etc., plus gamma square and we shall suppose this equation for reference as A. Now, you observe this is a quadratic equation in R. R square term, then R term, and then independent term of R, that is constant with respect to R. So, this is a quadratic in R. This is a quadratic equation in R. We can solve it for R, and we will get how many values for R. For a quadratic equation there will be 2 values, degree is 2, and therefore these the roots of this equation will be 2, and we shall denote 2 values of R it will have, and we will denote the 2 values of R by R1 and R2. So, this is quadratic equation in R and has 2 roots. Say R1 and R2. And thus we have expressed the point of intersection in this form, where this is quadratic in R, therefore it will have 2 roots or 2 values of R, R1 and R2. and we want to write a common point. So, point of any point we have written here on line, and that point we have put the condition as this is also a point on the sphere. So, therefore, this is the point of intersection, and because it involves r and there are two values of r. So, there will be 2 points of intersection. Thus, there are in general 2 points of intersection. And what are the 2 points of intersection? Which are L r1 plus alpha, putting r as r1, L r1 plus alpha, M r1 plus beta, N r1 plus gamma, and the second point is L r2 plus alpha, M r2 plus beta, and next will be N r2 plus gamma. So, these are the 2 points of intersection that we have, and thus a line intersects sphere in general in 2 points. Why we have written in general? Because that depends on the roots of this equation. If the roots of this equation are real and distinct, then we will get real distinct 2 points, and if the roots of this equation are imaginary, then the line will not intersect the sphere, or the line will intersect the sphere in imaginary points. That means no real intersection will happen. That we have seen the 3 cases earlier. And if the 2 roots are equal, the roots of this equation are equal, then the line will intersect the sphere in coincident point, single point, and in that case the line will be tangent to the sphere. So, thus this gives the intersection of a line and a sphere. Now, we shall see what is the meaning of power of a point. See, for this we will consider power of a point. What is meaning of this? Suppose this is a sphere, and now a point we shall consider as somewhere here. So, I shall consider a point here or anywhere on this side or on that side, and we will draw chords passing through that point to intersect, a line passing through that point to intersect the sphere. So, first I shall consider the point here, that is a point, and I have drawn the line passing through point A, and it meets the sphere in these 2 points P and Q. And what we will obtain is AP and AQ, the product of AP and AQ, and for that purpose we shall suppose LMN be the DRS, actually, or DCS, direction cosines of the line 2. Let, we shall start like this, let LMN be the direction cosines of the line 2. You refer the line 2 that we have written earlier. What was the line 2? X minus alpha divided by L is equal to y minus beta divided by m is equal to z minus gamma divided by n. That is the line. In that line, LMN are the DCS. Here we have written. Then these are the DCS. So that what is if these are the actual direction cosines, what is relation L square plus m square plus n square? This is exactly equal to 1. And therefore, if these are equal to 1, then what about the equation? This equation will become these are L square plus m square plus n square is equal to 1, and the equation is r square only. R square, this term is r square plus 2r into the bracket as it is, and this next term will be there, this one. Then that r, you see, this is the equation. Then we have to refer this equation, and then the equation A becomes, then, or we can write from this. Then what we will have is what is distance AP. So the coordinates of A are alpha, beta, gamma. We have already considered line passing through this point A, alpha, beta, gamma. Let A be the point, alpha, beta, gamma, and let the line passing through A, that is the line to intersect sphere in points P and Q. Let the line to intersect the sphere, that is sphere 1, in points P and Q. Then what is the AP? AP will be R1 and AQ will be R2, that is the distances. Then P will be, we will have then we have AP is why AP is R1 and AQ is R2, because there are two roots of this equation A, and this gives the values R1 and R2. Or if you consider these are the 2 points we have written L R1 plus alpha plus etc. So if the coordinates of P are the first, then what is the distance between A and P? So if this point is P and we have written this point as Q, then what is the distance between AP, that is R1, because see L R1 minus L R1 plus alpha minus alpha means L R1. Similarly, by using the distance formula, so that will be actually the distance. Then we have AP is equal to, if this is the point, so AP is equal to, if you have considered this point as P, or which are, we can say P and this as Q, and Q is the point L R2 plus alpha, M R2 plus beta, N R2 plus gamma is the point Q. These are the 2 points. And now you see what is the AP distance. So A point we have supposed as alpha, beta, gamma. Then AP distance will be R1. You can use distance formula and verify this. Then AP is equal to R1 and AQ is equal to R2. So how it is so? Because if you use the distance formula, AP will be under root. See, under root of we will verify only L R1 plus alpha minus alpha, that is L R1 square, plus similarly M R2 plus beta and minus beta, that is M R1 not R2, M R1 square plus N R1 square whole square by distance formula. But we know that we have here L square plus M square plus N square is equal to 1, and R1 square is common. So therefore R1 square into bracket L square plus M square plus N square. So this will be under root of R1 square only, under root of R1 square, which is R1. So AP is R1, similarly AQ is R2. So that we have, and thus now from from this equation A, then from equation A we have, say I shall write here, then from equation A we have product of roots. R1 and R2 are the roots of this equation. So therefore R1 into R2, AP into AQ, that is equal to R1 into R2. And what is the formula for product of roots in a quadratic equation? See, if we have the quadratic equation as this one, ax square plus bx plus c is equal to 0, if this is the quadratic equation, and if it has 2 roots x1 and x2, then we have x1 into x2 is equal to c divided by a, and we have the sum of roots x1 plus x2 is minus b divided by a. So this is the result from quadratic equation, and that means x1 into x2, instead of x1 x2 here it is r1 r2, because this is the quadratic equation in R, and that is equal to C upon A. What is C? C is this last term. So this is the last term C, we should put it in bracket, and this is C divided by A. But you see this A is the L square plus M square plus N square, and that value is 1. So therefore R1 into R2 will be only this one, this divided by this expression C upon A, but this value is 1. So therefore R1 into R2 is alpha square etc., alpha square plus beta square plus gamma square plus 2u alpha plus 2v beta plus 2w gamma plus d. So this is R1 into R2, and this is independent of L m n, that is independent of, there is no term of L m n in this, which is independent, of L m n. And what this shows, or what this says, and that means this product AP into AQ is constant or fixed, because it does not depend on the direction cosines element, and therefore it remains constant, and whatever the direction of the line, we can have this product fixed. So thus this shows that, or thus, so if chords are drawn from a, or the meaning of this is, again you see, if this is the point A, if I draw this chord passing through this point A, and that intersects the sphere in these points, so this chord, then if this is the point P1 and this is the point Q1, then we have AP1 into AQ1 is equal to constant. So this is constant, or thus AP into AQ is equal to constant, or this means that or hence if chords are drawn from a fixed point A, if A is a fixed point, and chords are drawn to the circle, to intersect the circle, intersect the sphere, to intersect a sphere in P and Q. Chords are drawn in any direction, that is to be written here, mentioned, chords are drawn in any direction, because that it does not depend on the direction, in any direction, to intersect a sphere. Intersect a sphere at point or in point P and Q, then AP into AQ is constant. Here we have written that is AP into AQ is constant, or similarly AP1 into AQ1 is constant, or if you consider another chord passing through these points, that is P2 and Q2, then AP2 into AQ2 will also be constant. Then AP into AQ is constant, and this constant is known as the power of the point A with respect to the sphere. This constant So this is the meaning of power of a point A. So that means if you draw any chord or line intersecting the sphere in 2 points, then AP into AQ remains constant. So here that we will have AP into AQ is constant, that is equal to AP1, this is AP into AQ, and that is AP1 into AQ1, or that will be also equal to AP2 into AQ2, all are constant. And that's why, because why this is so, because this is independent, this product AP into AQ is independent of LMN. That means independent of the direction cosines of the line or direction of the line, and therefore it remains constant, and that is known as power of point. So thus we have seen that a line generally intersects a sphere in 2 points, because we get the common points equation as quadratic in R, this equation, and then we have seen what is the meaning of power of a point. So thank you for watching the lecture.